Alright, so what we want to talk about today is the basics of projectile motion. And the basic idea in projectile motion is anytime you take a simple object, let's say like my marker here, and you not only have the marker, let's say, move straight up like we've done before, we've looked at something moving straight up and down, but now it moves in some type of arc. So I like throw the marker and it goes off at some angle and goes up in the air. And so the idea of projectile motion is before we used to, we'd have somebody drop some object and the object would fall straight down to the ground. Or the other thing we had before is we had somebody throw an object instead of off the ground. We had vertical motion, and someone would throw something straight. Or we would not necessarily throw it straight, but we would, let's say, we would have some object moving on the ground with some speed. But what we need to do now in projectile motion is we need to have our person throw an object, and when they throw the object, they're going to throw it up at some angle. They're gonna essentially like throw the marker and let it move through some thing. So when you have projectile motion, what you essentially have is you have motion that combines, if we're looking at it off a building, you would have, if you were to roll something, let's say off a table, let's say we roll something off a table. So initially, when the ball hits the edge of the table here, let's try to make this a little bit bigger. When we're talking about projectile motion, let's say our ball rolls off the table. Well, when the ball rolls off the table, it's going to be a combination of, in the X, it's going to continue moving with some initial speed. So you'll have the ball moving with some speed, but in the Y, it's going to experience free fall until it hits the ground. And so the idea is when you combine the X piece and the Y piece, the ball does something like this. It would roll off the table and move away and land some distance away from the table. It wouldn't just fall straight down here. It would roll off the table and land some distance away. And of course, the distance away that it lands is related to the speed at which you rolled it off the table. And so projectile motion is a combination of both Y and X motion. And so when we do this, the velocity now becomes a vector that's a combination of the X and Y pieces. Now the thing is in the X direction, the velocity is constant in time, and when you roll the ball off the table, the Y component gets larger because gravity is accelerating it towards the ground. So projectile motion is motion that's made up of X and Y components. Now, if you're standing here, let's say, and you're standing here on the ground and you want to throw your projectile up. Well, it turns out when you throw a projectile, it's going to take a certain path, and the path that projectile motion takes when you launch something into the air, it's a parabola. And it's a parabola because we said that this initial velocity that we throw it with when we angle it up, it has X and Y components. And so as the ball is traveling in the air, the X component is constant in time. But what happens is the y component changes. And so as our projectile moves through the air, the y component changes. So when you launch a projectile upwards, it maintains its x speed, but the y part changes because as the ball goes up, the y velocity gets smaller because gravity slows it down. Then at the top, at the very top here, the y velocity goes to 0. Velocity in the y is 0 at the top, and then gravity starts to reaccelerate it back to the ground. So it speeds it, gravity slows it down going up, then speeds it up coming back down. So the y component changes, the x component is constant. And the reason, because gravity needs so much time to slow it down and so much time to speed it up, you get this parabolic shape. Now what happens is the squishiness or whatever of the parabola, the shape of the parabola will change with the initial angle of launch, but you'll always get this parabolic shape. But we have to condition that with in the absence of air friction. With air friction, you smush the parabola and make it non-completely parabolic. But the idea is that whenever you launch something, as long as air resistance isn't a major factor, you'll get this nice, you get a parabolic shape because gravity needs so much time to slow it down, and then it uses that exact same amount of time to speed it up. And so this covers kind of the basics of parabolic motion, that it's a component. Parabolic motion is a combination of x and y. The x is constant in time, it doesn't change, and the y changes because the y velocity, if you throw something up into the air, the y velocity will slow down, reach 0 at the top, the highest point, and then it will start to accelerate back down towards the ground. And because of this, you get a parabolic shape. And as we said, the angle that you throw it at changes the size of the shape of the parabola in the absence of air friction. Or the other example we looked at was the idea that if you roll something off the table, when you roll something off the table, because we said that this motion is made up of two components, x and y, in this case, the y, this y motion, this is free fall. You have free fall in the y because there's no initial y component, it's just falling off the table. Then in the x, you have some constant x velocity. So the x velocity just determines how far away from the table you land. The y gives you the amount of time you have. So the faster you roll the object off the table, the farther away it lands, but the table height fixes the amount of time because you only have free fall time to deal with. Because it's like, in the y, it's no different than dropping the ball. In the x, you gain the distance away from the table.